So, on this episode of Mathmeotics, we're going to continue or re-talk about the properties of quality, algebraic and geometric. So the reason that we need to talk about this, let's say we are familiar with the algebraic equation. Let's say we have 2x plus, let's say 6, and that's going to be equal to, I don't know, let's just say 10. And we know that I need to do the inverse property, and I'm going to subtract 6 from both sides, and that's going to give me 2x is equal to 4. And then I know that I need to divide both sides by 2, and that's going to give me x is equal to 2. Okay? Well, the algebraic properties, this is an equation, and the algebraic properties, what it says is that whatever I do to one side, I can do to the other side. That whether or not that's addition, subtraction, multiplication, division, distributive, and then we also have these new ones. They're not really properties of, they're properties of equality. There's reflexive, symmetric, and transitive. And then, of course, the substitution property is something that's a little bit separate from those. These right here, these are our properties of congruence. Now, the first property that we have, the addition property, let me go ahead and get started here and explain these. The properties of equalities, what this states is that if I have A is equal to B, then that lets me know that whatever I add to A, and as long as I add it to B, it's still going to be A is equal to B. The same thing happens with the properties of subtraction. If A is equal to B, then whatever I subtract from A, as long as I subtract it from B, it will still give me A is equal to B. And same with multiplication. A is equal to B, then A times C is going to be equal to B times C. Note, I'm doing the same thing to both sides. All right, and then the division property says that if, accidentally didn't mean to do that. Division property says that if A is equal to B, then A divided by C is equal to B divided by C. Note, C cannot be equal to 0. Okay. Now, distribution property. If A is equal to B, then A times B plus C is equal to, actually not the A is equal to B. We're just going to say if A times B plus C, that's going to be equal A times B plus A times C. Okay, now let's talk about some of our properties of congruency. Oh, and down here is substitution. All that says is that for if, oops, I didn't spell that right. If A is equal to B, then I can replace A with B. And by the symmetric property, so now let's talk about the symmetric property and the reflexive property and the transitive. The reflexive property says that it's just A is equal to A for any value. So, for example, I could say 1 is equal to 1, 2 is equal to 2, angle 1, or we can say angle 1 is equal to or congruent to angle 1. Okay? It's equal to itself. Think of a reflection or a mirror. Symmetric property is a little bit different. Symmetric property says that if A is equal to B, then I can say B is equal to A. So what that allows me to do is if on the instance when I'm solving my equation and I get, let's say, 12 is equal to x, the symmetric property is going to allow me to say that x is equal to 12. Okay, lets me turn that around. Now, the transitive property oftentimes gets confused for the substitution. So if A is equal to B and B is equal to C, then A is equal to C. What are you doing, you crazy? Hey, cat, stop. Stop. My cat is playing with the cord, so I'm trying to get him to stop. Willow, hey, psst, leave that alone. Sorry for this interruption. All right, now back. Okay, so another example is, okay, so to see the difference between, say, substitution and transitive. Okay, substitution says that if I have an equation and I have, let's say, 2x plus 4, and let's say that's equal to, let's say that's equal to 12. Okay, and that means that 2 times 4 gives me 8, 9, 10, 11, 12. So then let's say let x is equal to, and that's going to be equal to 4. All right, so that lets me know that substitute in 2 times 4, substitute that value in, plus 4. All right, that's going to give me 12. That's going to give me 8 plus 4. 8, 9, 10, 11, 12. That will give me 12. 12 is equal to 12. All right, that works out. But the substitution property is saying that we can substitute that value in for this. I could even, for example, say this. Let's say x is equal to 2y plus 3. And I say that x is also equal to 9. That lets me know I can substitute this value in for x. So I can say 9 is equal to 2y plus 3 and solve for y. That's what the substitution property says. But the transitive property states that if I have an equation like, let's say, 2 plus 4, 5, 6, that's going to give me 6, all right? And I know also that the square root of 36, or even, let's see, 2 times 3, I don't know why it's doing that. 2 times 3 is also equal to 6. That lets me know the transitive property, I can rewrite this and say 2 plus 4 is equal to 2 times 3 and work out my problems that way. So then 6 is equal to 6. That's what the transitive property states. And that is all of the properties of equality and what they can do for you. In the video that I already posted, but you can watch that video if you haven't yet, I go over an example on how to do a 2-column proof using the properties of equality. See you in the next video. Have a good day.